Hello again, welcome to another lesson in geometry. Today we are covering section 11-2, surface area of prisms and cylinders. So we have some vocabulary first. We're going to write true or false for each of these. So a lateral face is a polygon surface of a solid. This is true. So for instance, a cube, the lateral faces are the squares around the edges, around the sides. So there are 4 of them. Okay, and each one of those is a polygon. So lateral faces are surfaces of a polyhedron. This is true. A polyhedron is a three-dimensional shape made up of polygons, usually more than 6 or more. So a lateral face may be a circle. This is false, so a lateral face has to be a polygon. And the base is a lateral face. This is false also. It's usually a polygon, but we call the base different than the lateral faces. The lateral faces are the polygons around the side, and the base is usually the bottom, okay, or the top. All right, oblique. Oblique is object is a slanting, not straight object. Okay, so oblique means indirect, not straight to the point. So an oblique object is not straight up and down. Okay. Other words, obliquely is the adverb. So an oblique polyhedron has no vertical edge, so an oblique prism is not a right prism. All right. So a right prism would have a right angle between the base and one of the lateral faces. So circle the oblique prism. It's going to be this one. You can tell how it's leaning to the side. Circle the oblique cylinder. That's going to be this one. You can tell how it's leaning to the side. With this guy, there's a right angle between the base and one of the lateral faces. And with this one, there's a right angle between the base, which is a circle, and then this part around the edge, which is actually a rectangle if you unfold it. All right. Number 7, complete with oblique or obliquely. So a right prism is not an oblique prism. Okay. It's not going to be slanted. And a right prism, your classmate answered the question obliquely. That means they answered it, but they went a roundabout way to get to it. Okay, on page 2, we have problem number 1, using a net to find the surface area of a prism. So what is the surface area of a triangular prism? Use a net to do this. So a net means we're going to unfold it and just find each of the areas separately. So label the missing dimensions in the net below. So our net has D. D is this piece right here. Okay, and it has E. E is that piece. So D and E are the same. So they're only going to measure the dimensions on D and E. Or on E, and then D will be the same. And then we have this 5 right here and this 5. Okay, so they match up here and here because they would fold up next to the D side. And then 6 is the other side that goes around the D. So it goes, this piece is D, this triangle right here, and it's a 5, 5, and 6 for the sides of that triangle. All right. And then the side of each of the rectangles is going to be 12. So we have a 5 by 12. That's this one. Okay, this is this 5 by 12. There's another one on the other side that's 5 by 12. That's that one. It matches exactly the same. And then on the bottom, there's a 6 by 12. That's this one. So like we said, D and E are the same, and the sides of E are also going to be 5 and 5. Okay. All right, so the altitude A of each triangle forms a right triangle with legs A centimeters and 3 centimeters. Okay, the reason why is if you look at one of the parts there, we have A for how tall it is, and then 3 and 3, because that 6 gets broken in half. So when I want to make the altitude with the right angle there, then I have an A by 3. Okay. Now the other side of this is also a 5, so we can use that as 2 numbers and the Pythagorean theorem to find what size of A is. So 3 squared plus A squared should equal 5 squared. That means A squared is going to be 25 minus 9, and A squared would be 16, and the square root of 16 will give us 4 here. So we can now have the area of one of those triangles be found because we know that this is 4 and this is 6. All right, so find the surface area of the prism. So our surface area is going to be equal to all of the sides added up. I don't like how they write this lateral area plus the area of the base. Technically, for a prism, the base should have been the triangle. This is a prism knocked on its side. But what they're saying in this case is we're going to find the bottom's area. Then we're going to find all of the other areas, which are two triangles and two other rectangles that go around the bottom. All right, so areas of two lateral rectangles plus the area of two lateral triangles plus the area of the base is what we're looking for. So area A plus area C, those are two lateral rectangles. They are both the same size. They are 5 by 12 and 5 by 12. Okay, that's C and A up here in our net. Okay, and then we're going to find the area of D and the area of E because we have two lateral triangles that are the same. So we're looking for D and E here. And we already found those dimensions. It was 4 by 6 for both of them. So in here we're going to put 1/2 4 by 6 and a 1/2 4 by 6. And then lastly, we need to find the bottom piece. And that's B here. That's our regular base. So that's a 6 by 12 rectangle. And then we do some math here. 5 by 12 will give us a 60 area. 5 by 12 will give us a 60 area. Half of 24 will give us a 12 area. Half of 24 again will give us a 12 area. And then our last one is 72. If we add up all those things, we're going to get 216 for our total area. So the area is 216 centimeters squared. All right, so the real way that we do prisms, because we don't usually unfold it and talk about it. Instead, we just say, oh, the area of prism is the lateral area plus the surface areas of the prism, okay? And surface areas of the prism. So we're talking about lateral and surface areas of the prism, and our formula is going to be surface area is equal to the lateral area plus 2 times the base. A prism will always have a top and bottom that are the same. So in this rectangular prism, we have two rectangles that are exactly the same on the top and bottom. If we look back at this example, which is why I didn't like this one first, this is a triangular prism. So the bases are actually this triangle and this triangle that are exactly the same. Okay, so that's the 2 times the base. All right, let's finish up here. So write a formula for the surface area using the perimeter and using P and H here, where P is our perimeter and H is our height. Okay, so surface area is equal to P and H. So the surface area in this one is going to be our perimeter times our height plus 2 times B. Now, where does the perimeter times the height come from? All right, so if we unfolded all of these parts around, so we got the red in top and bottom, but let's say we had green that was all the way around, right? If we unfold that green, what we end up with is 4 rectangles. This is the front and the back, and then this is the left and the right, okay? And then each of those rectangles all have the same height of H, okay? So what we can do is just think of them as one big unfolded rectangle, and the big unfolded rectangle has a distance of P across, the perimeter of starting from here and walking around, okay? All right, so then we can do one big rectangle where the base or the length is perimeter and the height is our width, okay? And then we have to still add on the 2 bases. All right, so use the formulas to find the surface area of a prism. What is the lateral area of the prism at the right? Complete the flow chart. So remember, our lateral area is going to be the perimeter times the height. So we're going to think of making this unfold to one giant rectangle where this is the length and that's our width, okay? So our perimeter here is going to be, let's see, we have 1, 2, 3, 4, 5, 6 identical sides. Each one is 6 long, so a perimeter of 36. Our height here is 12. So the lateral area is going to be the perimeter times the height, which is 36 times 12 for a total of, what does that multiply to? 36 times 12 will give us 432 meters squared. So that's our lateral area of our prism. Now that's not the whole surface area because we never found the area of the hexagon basis, which we'd have to add on. So remember, surface area is the lateral area for a prism plus 2 times the base because we have 2 identical bases. Okay, next we have theorem 11-2, lateral and surface area of cylinders. So just like a prism, the lateral area is the distance around, okay? So we have first our bases, so these are our bases, and then the lateral area is going to be all of this stuff that goes around the 2 bases, okay? So in this case, it's a little bit different because we have a curve on it. It's not polygons around the sides. So use the diagram at the right to complete the formulas below. So the lateral area of a right cylinder is the product of the circumference of the base and the height of the cylinder. Okay, so we can use one of these 2 formulas. The lateral area could be 2 pi r times h or pi d times h. Now why does that work? So if you take a soup can, okay, and you cut the label straight like this or just peel it off, and then you unpeel that whole label from the can, you're going to get a rectangle. And that rectangle is going to have a height of the can, okay, in this case h. And then this part is actually going to be the distance around the base or the top or bottom of our circle. And the distance around a circle is circumference, so that's going to be our circumference. And that's why the lateral area is really equal to the circumference times the height. All right, now we also have to add on the 2 bases. So the surface area, the total surface area, is the lateral area plus 2 times the area of the base. Now a base is a circle on both, so pi r squared times 2 would give us the area of the bases. And then we also need to add on the lateral area. So let's put in pi d here, or you could put in 2 pi r h. Okay, so pi d h. I lost my h in there. Okay. All right. Number 3, finding the surface area of a cylinder. So we're going to actually do this. So here is our cylinder. This has a height of 9 and a radius of 10. And we want to know what is the total surface area of the cylinder in terms of pi. So once again, 2 bases, so we're going to use the formula pi r squared because our bases are the circles on the top and bottom. That's this circle here and this circle here. So pi r squared goes there. And then we have to find the lateral area, and the lateral area is the height times the circumference, which will give us that big rectangle that goes around. So this will be 2 pi r h. So 2 pi r will give us our circumference times by the height. Okay, and that's the area of that rectangle that we would get if we unfolded the lateral area of the cylinder. So we're going to get 2 pi times 10 for our radius and 9 for our height. That gives us the lateral area. And 2 pi times 10 squared, this will give us the area of the 2 bases. Not just one, but both of them. So 2 times 10 is 20, and 20 times 9 will give us 180 pi. And 10 squared is 100, and 2 times that will give us 200 here. So this is going to be a total of 380 pi. Now we were asked to put our answer in terms of pi, so we're done here. This is 380 pi centimeters squared. Problem number 4, finding the lateral area of a cylinder. So a stencil roller has a height of 1.5 inches and a diameter of 2.5 inches. Okay, so a stencil roller is just a cylinder, okay? And it has a handle attached to it, and you roll along the cylinder and it leaves the stencil from whatever was on the edge of the cylinder, okay? All right, so we have a height of 1.5 inches and a diameter of 2.5. So that's 2.5 inches, and here's our height of 1.5 inches. Now, when we're rolling along, we're only going to stencil out the stuff that's around the side. So that's what we're looking for, is what's the area you get covered by rolling it one time. So underline the correct words to complete the sentence. The distance that is covered in one turn is going to be the circumference, okay? Not the diameter. The diameter is the distance across the circle, but we're going to roll that circle one time, so we're going to cover the circumference of the circular base of the cylinder. So this is definitely not a prism, okay? Find the area of the roller covers in one turn. So our lateral area is all we're looking for. We don't care about the circles on top and bottom here, our bases. And we can use pi times diameter times h. Remember, this first part is our circumference, and then h is our height of our cylinder. So we're going to do pi times 2.5 times our height of 1.5. And if you multiply that on the calculator, you're going to get about 11.780972. Keep on going. But we're rounding to the nearest tenth, so we're going to put 11.8 inches squared. Okay, lastly, we have a lesson check, which tries to do a better job of telling you what a cylinder is like. So remember, a cylinder is created from having two parallel congruent faces, and then rectangles all the way around connecting them. Okay, so in this case, we have a trapezoidal prism, because we have a trapezoid on the top and bottom that are parallel and congruent to each other, and then we have rectangles all the way around. We also could have triangular prisms. Those are triangles on the top and bottom, parallel and congruent triangles with 3 rectangles all the way around. Okay, or we might have a pentagonal prism. That's a pentagon on the top and bottom that are congruent and parallel, and then there'll be rectangles all the way around. So a prism is made up of a top and bottom with lateral faces of all rectangles. All right, so write the name of each of the 6 faces of the prism in the correct place of the Venn diagram. So since this is a trapezoidal prism, because these two shapes are parallel and congruent, those are going to be our bases. So in here are our bases, and we're going to put A, B, C, D, and E, F, G, H. Okay. Now there are another set of parallel faces. The other set of parallel faces are the top of this trapezoidal prism and the bottom of this trapezoidal prism. They're still parallel because the top and bottom of trapezoid are parallel to each other, so their faces will be parallel too. So we're going to put those here, B, C, G, F, and A, D, H, E. All right. And then we have 2 other congruent ones, but these aren't parallel. Those are going to be our sides. So this one and this one. They're the same rectangle, but they're not parallel to each other. So A, B, F, E. And C, D, H, G. Okay. So name the bases of the prism. Our bases are going to be these 2 in the middle here. So A, B, C, D, and E, F, G, H. Those are our trapezoidal bases. And name the lateral faces of the prism. The lateral faces are going to be all the rest. So there are 4 lateral faces because our base has 4 sides. Okay. So this is going to be A, B, F, E, comma, C, D, H, G, comma, B, C, G, F, comma, and A, D, H, E. All right. Check off the vocabulary of the words you understand here. So right prism, oblique prism, you should have an idea. So remember, right prism, the top and bottom, the line that connects them from a vertice to vertice will be a right angle. Oblique prism is going to lean over when it's connected. A right cylinder, that's a cylinder that's going to have a right angle in here. An oblique cylinder would look like this, a leaning over cylinder. Okay, so not a right angle in there. All right, explain how well you can find the surface area of a prism in a cylinder, and you should be in here. And this is our first section of chapter 11. So notice we skipped section 11.1. It was not in our standard, so that will not be on our test.